Welcome to our webinar. MyPV, hot water and space heating from photovoltaics is our topic, and I'm looking forward to present the MyPV portfolio, to present our solutions for this topic. The future is going to be electric is one of our slogans, and I'm going to show you what it's all about. While I'm talking today, I will focus on the slides during the presentation, but at the same time, my colleague is in the chat window. So if you have a question while I'm talking, do not hesitate, just enter the question in the chat room and my colleague Talal will do its best to answer your question. Thank you, Talal. You already mentioned that in the chat. Perfect. Okay, and another point, we are going to provide the slides from today's webinar after the session, as we do it every time. And from tomorrow morning, we will also have the record of the webinar online. So for all of you who cannot participate for the full time, it will be easy to check it out at the later stage. Nevertheless, I hope you will stay with us now, because the things that I'm going to show you will be very interesting. This is what I'm expecting. And I would like to start with a short introduction of MyPV. And the guy on the top is Dr. Gerhard Wimpler, our managing director. And Gerhard has more than a few decades of experience in solar electronics design. He started the division of the inverter production at Fronius a long time ago. In the meanwhile, he was also managing director of a factory that produced conventional solar thermal systems, flat plate collector systems. And my new colleague, Talal, who is with us in the chat right now, is the guy in the middle here. He will take over the area of international sales. So I'm really hoping that you will have a lot of contact with Talal, and there will be a lot of business opportunities for both of us. And me, myself, I'm at the bottom here. I'm at MyPV for 4 years now, a little longer actually. And before I started at MyPV, I also worked in the field of research and development of conventional solar thermal systems. And from that point of view, we are absolutely aware that conventional solar thermal systems actually they are at the end of their development. Nowadays we have PV. PV has become so cheap that we make heat production from the sun with wires instead of pipes nowadays many times easier on technological terms, and we make it also cheaper. This is the point, and this is the base for our solutions. Yeah, there are some milestones. Actually, we were founded as a distributor, but during the years we have changed our business model. We have become a pure manufacturer when we introduced our first invention, the Elva, in 2014. The whole story of a production company began. And during the years, there are also some AC solutions for on-grid systems. And the recent innovation was the introduction of the Ector product family. And these are the main solutions that I'm going to show you today. First, before we go into it, let's deal with the general question, hot water and space heating from photovoltaics. Why is that? And I already mentioned it. We see that solar thermal systems are at the end of their time. What we have had is an amazing price decrease of PV systems, and this decrease is still in progress. And this decrease is the base of all our solutions. It would not be possible without this development here on this slide. And nowadays PV has become so cheap that we can also create heat directly from PV. This was unthinkable, let's say 8-9 years ago, because at those days PV power was too expensive to think about power to heat application. But these things have changed completely. And nowadays it's so easy, my 5-year-old son would be able to connect the system together. And this is what I'm going to show you now. it is in the webinar today, it's all about single family homes. Actually, MyPV also creates projects for apartment buildings. We also have commercial projects, or actually we are supplying the components to the installers and to the planners for commercial projects as well. But the webinar today is mainly about a single family home. Most people here in Europe, they are aware of their demand for electricity in their single family home, because one time a year the energy supplier sends us a bill and we have to pay for it, and on the bill we see that we on the average we consume electricity of about 4,000 kilowatt hours per year. This is an European average household. But hardly anyone is aware of one simple fact. For a 4-person household, we are using approximately the same amount of energy for hot water heating. And of course, PV can cover this segment of hot water heating as well very easily. And then there's a brand new topic. It's about space heating, electric PV powered space heating. But for this topic, you have to focus on one important thing. The demand for heat energy matters. This is not the right technology for old buildings. For example, the building where I'm living in would not fit for this technology. I'm using 6 tons of wood pellets per year. This is exactly the energy that is on this pie chart, 30 megawatt hours a year. Therefore, PV power would not be the right technology. We can do hot water heating in every case, for old buildings, for new buildings. This is every time possible, but when we are thinking about electric space heating as well, this has to be a modern building, it has to be a low energy building, a passive house maybe. Good. Then it's all about energy storage. We want to use the PV power for ourselves, and the most common way to store energy is of course the battery. We are all aware of that, but typical storage capacities in single family homes, they are about the size of 5 kilowatt hours to 10 kilowatt hours. And this storage capacity needs to be bought for a huge investment. This is still the case. As a cheaper alternative, you can use a MyPV solution to increase your self-utilization ratio in your building. And see there, in a 300 liter hot water boiler, we can save 50 kilowatt hours of energy when we increase the temperature to a certain level. And to be clear, MyPV can be a cheap alternative to battery systems, but we do not compete with batteries. Very important. We have many very successful cooperations with battery manufacturers as well. And when you combine both technologies, you can increase your self-consumption ratio even higher, but the priority should be on the battery then. This is what we recommend as a manufacturer of power-to-heat systems, because once it is heat in the hot water boiler, we cannot get back electricity out of it. So power-to-heat in a residential building should always be the last step. If there is a battery should have priority before power-to-heat. And there are a few different solutions for hot water heating. The whole story began with this product here. It's the Elva. Elva is an abbreviation. It means electric water heater. Actually, it's the only DC solution in our portfolio. For the Elva, it is possible to connect PV panels directly to the immersion heater. And to have a better idea of the product, I'm going to show you a model of Elva. And therefore, I try to switch myself on the big screen now. Please, Talal, give me a short feedback if everything's okay, if the people can see me now. I assume it works, so I will continue. Thanks, Talal. Perfect. Nice teamwork today. We are on different locations, so we are also communicating via the chat here. This is Elva. Obviously, it's an immersion heater. Okay, what is special about this immersion heater? Because immersion heaters like this, they are available on the market for decades now. You can buy them in a do-it-yourself market. This is not the big story. what is the big story? Actually, it's the know-how from MyPV, because the MyPV know-how makes this immersion heater PV ready, photovoltaic ready. It makes it PV ready because of linear power control. This is what we do. This is our basic know-how, because PV power changes all the time, and what we are doing with our electronics here is adjusting the power output on the immersion heater accordingly. So the immersion heater is inside a hot water boiler or inside a storage tank. Both is possible. The heating elements are 45 centimeters long, and to connect the Elva to a boiler there is a 1.5-inch connection thread. This is a standard thread. You can find it on many tanks. So what is outside the tank is this control box here, and beside the electronics for linear power control there is also an MPP tracker integrated. But this is only the case for this product here, because at the bottom we have multi-contact plugs. We are directly connected to PV panels. There is no inverter which can do the MPP tracking, so we have to do the MPP tracking. The input voltage range on this multi-contact connections has to be within 100 to 360 volts. For a 60 cell polycrystalline panel I'm talking about 4 to 8 panels then. You adjust the target temperature that you want in the boiler on this rotation knob here, and to have an information about the current device status there are 3 LED lights on the surface. DC Elva also has a data log integrated with an infrared interface from MyPV. You would be able to have access to the data logger. You can change factory settings if you like. And while I'm talking, you see that there is a mains cord on the bottom here. This is an option. It's not necessary to use it. We have customers who have never ever used this power cord here. But if you use it, if you plug it into a socket, then Elva checks in the afternoon whether the desired hot water temperature is reached or not. And if there was not enough PV power available, the Elva will automatically start the boost backup mode. For the DC operation with power from the panels, there is a power output range from 0 to 2000 watts possible. The optional backup works with 750 watts. Of course, you can cut off this European mains plug if you don't like it, and you can connect the wire, the cord, directly to a power circuit. This has no influence on the warranty, so you can do this if you like. Well, yeah, this is Elva. Yeah, the first product. When we started with Elva in 2014, there was one big problem with this unit, and it was a very simple one. Elva was ahead of its time. So in 2014, everyone was used to work with solar thermal systems, with pumps, with pipes, with expansion vessels. We were used to check the anti-freezing liquid one time per year, and no one thought about using PV power directly for heating. But we did, even in 2014, and now we have 2 little wires instead of this whole plumbing stuff. And this is so easy, it cannot be easier. So here are the technical facts, the data. I have mentioned most of them already. One thing that is special on Elva is its possibility to work in the stratification charge mode with a second unit. So let's assume you have a huge storage tank. Then you want to have a certain level of temperature for your comfort available at the top of the boiler very soon. And one way to do this is to use an Elva on the top and an Elva on the bottom. The Elva on the top has priority, of course, and due to this smaller volume above the heater, it can reach target temperature quite fast. And once this happens, the rest of the PV yield goes to the unit at the bottom. In Europe, it's very common to use the Elva with the higher priority in a hot water boiler and the Elva with the lower priority in the storage tank, which is next to the boiler. Actually, this absolutely does not matter. Both is possible. and you do not even have to install a special communication wiring between those two units. They can communicate with each other via the DC line automatically. So it's very easy to install and a really smart solution. It's the only solution that can be compared one by one with a solar thermal system, because we are using all the energy from the roof for heat production only. It's not possible to use this PV power for electrical applications, for TV, for light or something else. It's not possible to combine it with a battery. It's for direct connection with PV panels only. This is not the case with all our solutions that I'm going to show you now. Now we are dealing with AC solutions. Now we are on the grid, and now it's mainly about using excessive energy, energy that usually would be fed into the grid. This is what we want to use for heating here. So the question is, how much energy is available in the feed-in point? This has to be determined in some way. This has to be measured, and one option to measure this is the MyPV power meter. It is a Modbus meter actually. It is installed in the feed-in in the electric cabinet actually, next to the utility meter of the energy supplier, and it measures the power on all three phases. By the way, it also works in single-phase systems, no problem. Just leave the other two CT clamps beside. So there are CT clamps to measure the current. This makes the installation of the power meter very easy, because you do not have to cut up the phases of the feed-in point. You can use the clamp-on transducer to do the measurement. And the communication in between the power meter and the other MyPV power controller happens via Ethernet. So the power meter here has an RG45 socket to transmit the excessive power informations. What is with the power meter in the box are 3 CT clamps for 60 amp measurement. Optionally, we can also supply you with bigger CT clamps, for example, when you are creating a commercial project or something else. Okay, if you do not have a network, if you do not have a router available, then it's also possible to connect the power meter with the other MyPV product directly, but therefore you have to use a so-called crossover patch cable. It's not the standard Ethernet cable, it's a crossover patch cable. But this means you do not have to install a router or a network every time. Good. For retrofitting systems where it's very hard to install an Ethernet wiring, it's very common to use so-called power line adapters. So the excessive power information is transmitted via the AC power installation in the building temporarily. This is possible, this is done many times, and such power line adapters are available in do-it-yourself markets or in shops. So this is not provided by MyPV. This is available for little money in many shops. Good. This power meter that I have shown now is an option. It's not necessary to use it for the measurement. It's not necessary to use it in case that there is another signal source which is already compatible to MyPV. And there are many brands that are already compatible with MyPV. For example, here are inverter manufacturers, battery manufacturers, or smart home manufacturers. And if such a brand is available for your project, and if this system is available to provide the excessive power information to our power stages, then you do not have to use the power meter additionally. And now we are talking about the first power stage from MyPV. It's the AC Elva-E. Of course, Elva, the abbreviation, means electric water heater again. The letters AC at the beginning tells us it's an alternating current product, of course, and the E stands for Ethernet. So the physical properties, the dimensions of the AC Elva-E are exactly the same as for the Elva that I have shown before. The most important difference of the Elva is that there are no multi-contact plugs on the bottom. There is no direct connection to the PV system. The AC Elva-E takes all the power it consumes out from a socket. But from this socket, it just takes the amount of power that would be fed into the grid. And this changes all the time. We have clouds moving on the sky, so the PV production changes. At the same time, loads in the building are switched on and switched off. So the balance in the feed-in point, the balance which is too much in the building, changes permanently. And what AC Elva-E does, it always ensures the balance in the feed-in point. It adjusts its power output very fast and very accurate. Let's assume you just switch on the light in the living room here. This means that from this moment forward you would have less excessive power available. AC Elva-E will immediately reduce its power output to ensure that there is no feed-in and no import from the power grid. The control speed, how fast the AC Elva-E reacts, depends on the signal source. It's the fastest way to use the device is of course the MyPV power meter. 1 time per second for each single watt. This balance is created in the feed-in point. And yeah, the socket of course can be replaced by a hard wiring. So also for the AC Elva-E it's allowed to cut off this main socket here, no problem from our point of view. And we recommend to use a separate fuse for this current circuits, because the power output of the AC Elva-E goes up from 0 to 3 kilowatts. 3 kilowatts can activate a fuse, can blow a fuse, and this is what we don't want, of course, so we use a separate fuse to make this device safe. Good. Technical data. I have mentioned the most of them. What is very important to know is that our way of power control works with pure sinusoidal current consumption. MyPV is adjusting the power output on our devices like a PV inverter works. We are modulating a PWM signal to create a sine wave, and this is very clear. It's a quality symbol. So we are compliant to the rules of the grid operators. For example, in Austria, in Germany, in Switzerland, where the rules are very strict, because we do not use thyristors. We do not use phase angle control. It's like a PV inverter working with a pure sinusoidal power output. Due to the fact that the AC Elva-E usually is connected with the signal source over a router, respective over a network, the device also has a web interface. So via an HTML file, you have access to the whole settings of the device when you are inside the local network. But also for remote control, it's possible to have a cloud connection of the device. But for these two things, the device has to be connected to an Ethernet router. It's not possible when you connect it to the power meter directly, for example. Then no one has access to the web interface, and of course we cannot connect the AC Elva-E to our online cloud. Also here the boost backup mode can optionally be activated. It's very easy in the web interface, just 2 clicks and then the setting is done. The factory preset is that the AC Elva-E is using excessive power only. So the boost backup mode is deactivated when it leaves the factory. Good, then it's all about increasing the self-consumption. For a normal single family home, we have, let's say, European conditions, 5 kilowatt peak system on the roof. We have an average self-utilization ratio of approximately 1/3. This is very low because production and energy demands they do not appear at the same time. So the rest of the energy goes back to the power grid, is lost for the building. And to increase the self-consumption, it's mainly about battery storages. you can install a battery and you increase your self-consumption to around 60% in this example. Alternatively, you can use an AC Elva-E from MyPV and see there the self-utilization ratio is higher at lower investment. Nevertheless, we do not compete with the battery. I already mentioned that. If you combine both technologies, battery and MyPV technology, you can increase the self-utilization ratio even higher to more than 90% in this example. If there is a battery should have priority when you charge it. This mainly depends on your local conditions. So this is the standard way in Central Europe. I already have experience, I have heard from countries where the tariff for electricity is different than here in Central Europe, and therefore it would be more interesting to use the power the other way around. But the normal way is to charge up the battery first, because once it is heat in the boiler, we cannot get back electricity out of it. For sunny days in autumn, it's not a sunny day today, but if it would be sunny, then we would have seen that a battery system would reach the state of full charge sometime in the late morning. And from this point forward, we would have a lot of remaining excessive energy available for power to heat applications. Good. The worst thing I can imagine for a PV system is when the PV system is shut down. This happens already in parts of Central Europe because when the operators of the power grids they see that they cannot put all the power away from the buildings because the power transmission is limited in the power grid, they need to shut down the PV system. And I can understand that from a technical point of view, but it's a disaster for our green philosophy, because we do not use PV power from the roof from this moment forward. It would be available, it would be green, it would be for free, and we do not use it. And what happens in the end? If in the evening when we need hot water to have a shower, then the gas boilers will do the hot water heating or whatever. This would be insane, of course. This is nuts. So let's use the excessive power at least for heating before we switch off our PV systems. This is very important. Good. How important the capability of MyPV for linear power control is can be seen on this image. So this is a cloudy day. The amount of excessive power changes all the time, and we only want to use exactly this amount, which is too much. So we have to adjust our power output from second to second to second. And this is what we see here in the blue area. The power output on the electric heater changes permanently, and we adjust accordingly to the conditions. There is a tool on our website that can help you figuring out what is possible for your projects. It's a MyPV Power Coach. It's actually, you can handle it like a toy. You see it in the background here. It's very easy to handle it. So you can adjust the PV system, you can adjust the demand for electricity and for hot water, you can adjust if there is a battery or not. And beside the fact that it can be handled like a toy, it's actually a serious tool. I recommend it to you for your plannings. I recommend it for you for your consultancy, and of course for your sales. For your sales talks. Use it and figure out what is possible and convince your client about the benefits. They can get an idea of what is possible, how the self-utilization ratio can be increased, what it means for the operational costs, and you also can get a suggestion of MyPV devices for the project that you set up here. So it's a tool, and I really want to recommend it to you to use it. So what we have seen so far, our Elva solutions, the gray DC Elva and the green AC Elva for on-grid systems. Before we start with the Ector power stage. I would like to know you a little bit better, and therefore I have prepared a short survey. Please do me a favor and give me a short information. What is your profession? Are you an electrician? Are you a plumber or working in the field of heating, ventilation and air conditioning? Are you a planner? Are you dealing mainly with on-grid systems or mainly with off-grid systems? So you can also use more than one answer here. Do not hesitate, just enter your profession. Of course, it's all anonymous. I just have an idea how many percents are working in this or that field. Thank you very much. There are already many answers so far. Maybe a few more seconds. Wow, thank you very much. Okay, I think okay, a few are still answering. Good. I think we can show it now. So 1/3 of you is dealing mainly with on-grid systems. A little more than a quarter is a planner or a consultant. Only 6% are plumbers, 14% are electricians, and 17% are dealing with off-grid systems. Very interesting. Thank you very much, ladies and gentlemen. And after this short break, we will continue with the Ector and the Ector 9S. When we started with this product and we presented it in November 2017, the people took a look on this device here on the right, and they thought, okay, this is a box on the wall, there is a color touch display on it. Okay, this is obviously some kind of smart home system. Actually, these people were completely wrong. MyPV is not producing smart home systems. The Ector is, technically speaking, a photovoltaic power stage. It's a power stage. You can adjust the power output on an electric heater, on a pure resistive heating element. In doing so, we can make this stupid on-off electric heating element PV ready. We make it PV ready in terms of linear power control. So there is a European mains plug on the bottom where we connect a standard heating element. A standard heating element that before was just able to be switched on and off and nothing else. So this is a European main socket. Of course, there's a version for international markets with an adapter here. And what we see here are many unique sales points. Number one is the size. This thing is so small, I can keep it in one hand. Then we have a very intuitive way to control it. There is a color touch display on the device. Everything can be plugged here on the bottom is unique sales point number 3. Not just the load, also the communication, of course, it's an Ethernet connection. Also the temperature sensor. One sensor is always with the Ector delivered in the box, is pre-wired on this orange plug here. And on the right side here, there's a relay output, and depending on the operation mode, this relay output is used for different things. Unique sales point number 4. We have a flexible communication here. We can be controlled by the MyPV power meter, but we can, above this, can also be controlled by inverter manufacturer, battery manufacturer, and smart home manufacturer. And for all of you who want to create their own home automation system, we are going to offer the communication protocols of our devices for the Ector, for the green AC Elva-E, for everything that you want. We do not insist on using our power meter. We offer you the communication protocol of our product. Good, this will have been unique sales points, 4 of them. What we recommend for the installation is using a cable cover, as it can be seen on the image on the right. And when you install it that way, then it looks professional. And all the cables and the wires, they disappear behind this cover. And then it's also a nice, beautiful installation, what we hope you do. Good. Technical data. You will receive the slides after the webinar. I'm not going to deal with every line here, but also the Ector has a web interface. So many settings are possible on the color touch display, but more settings are possible with the web interface. So when the Ector is connected to an Ethernet router, you have access to a local web interface, and in that web interface much more settings are possible than on the display. And for Ethernet connection via router, also the cloud integration of the Ector is possible. And now I want to talk about the Ector 9S. It's the big brother of Ector, and obviously there is the same image on the right. This is not a mistake. We actually have created a three-phase product for a power control from 0 to 9,000 watts in the same case as the Ector. And it's called Ector 9S. And see, at the bottom, still everything is pluggable. So all the loads for a three-phase product, it's not necessary to open a case. It's not necessary to do the installation with terminal blocks. It's not necessary to install PG connections. It's all pluggable here at the bottom. And this is very interesting for your time or for the time of your clients that are installing the devices. Very interesting. Good. And then we have the technical data also for the Ector 9S here. One thing that I have to talk about is our ability to control all three power outputs linearly. So most of the competitors, or practically all our competitors, are working in that way. They are adjusting the power output on one phase from 0 to 3 kilowatts. And from a certain level of excessive energy, they are switching on phase 2 and then they are switching on phase 3. But actually, their ability of power control is from 0 to 3 kilowatts. In that way, also the Ector 9S works. But what is special is the ability of this product to change the controlled output from output 1 to output 2 to output 3. This is not possible by our competitors. And this offers a few interesting application modes. And of course, I'm going to show them to you. If you use the Ector 9S for retrofitting, for example, you say, okay, I have a hot water boiler and there is already an immersion heater inside. I want to keep this immersion heater to avoid all the hydronic installation. Then just take a look on one important thing. This three-phase heater needs a neutral conductor. It has to be connected by a star connection, not by delta connection. This is very important, otherwise we cannot use the three-phase load. For all of you who want to have the security that all the components work together, there are also optional accessory parts. A single-phase 3 kilowatt heater for the Ector, a three-phase 9 kilowatt immersion heater for the Ector 9S. So just in case you want to have everything from MyPV, of course, we would be glad to offer it to you, and this is an option that I can offer. Good. Operation modes. There are 8 operation modes when you pick the Ector outside, out of the box. It's not necessary to pay a special fee or something to have additional operation modes. All of them are available from the beginning. These 8 modes, these are, let's say, standard applications. They fit for, let's say, 90% of all the projects. Of course, they cannot fit for every project. So the question is, what are we doing with the remaining 10% of the projects? Can't we create these projects? Of course we can. And the answer is, again, our open communication protocol. We are offering the communication description, and you program the Ector or the Ector 9S in a way that works for you. And then you can also create this special project, because of course there are always projects that are special in some way. Of course, these are standard modes, these 8, and they cannot fit to every project, of course. Standard mode 1 is the most common mode, of course. It's the hot water mode. For the Ector, for the single phase Ector, you know, the one with the socket on the bottom, it works with 3 kilowatts immersion heaters, and for the Ector 9S it works with 9 kilowatt immersion heaters. The excessive power information can be provided by the power meter or by a compatible manufacturer, or you can control the device yourself with your own home automation system. And then there is this special thing about the 9S. We can change the linear controlled output from output 1 to output 2 to output 3. And one benefit is on this schematic here. Let's assume you have a huge storage tank, a very tall one, and of course it would be easy to have a 3-phase heater at the bottom, and we would be able to inject all the excessive power to this tank. The disadvantage would be that it will heat up relatively slow. What is better in terms of stratification charge is to start the heating at the top. So we have a hot comfort zone achieved earlier in that way. And in that case, we are using 3 single-phase 3 kilowatt heaters. This also works with the accessory part that I have mentioned here. And for the single-phase heater, of course, you are allowed to cut off the mains plug either. By the way, this is necessary for this mode. Otherwise, you would not be able to connect it here. Let's assume now we have 1 kilowatt of excessive energy. 1 kilowatt is too much in our building. What is the Ector 9S going to do? It will take this excessive energy and will start linear power control at the heater at the top. Now let's assume we have 4 kilowatts of excessive power. What will happen? The Ector 9S will switch the phase for the heater on the top statically, 3 kilowatts on. And it will change over the linear power control to the heater in the middle. And in that way we have a very smart and accurate linear power control on 2 heaters. And now you can already imagine what happens once we have 7 kilowatt of excessive power. The Ector will switch the heater on the top and in the middle statically with 3 kilowatt each, or by the way, whatever the nominal power is of the heater. It's also possible to have 3 heaters with different nominal powers. And it will change over the linear power control to the heater in the bottom. And in that way, we have a much smarter stratification heating in the huge tank here. And this is only possible when we, by the way, that we change the control phase from output to output. Good, then there's a mode 2 stratification charge mode. For the single phase Ector means that we are using the integrated relay to switch over from one single phase heater to the other, and one after the other is supplied linearly with power. For the Ector 9S, this means that we are using the same relay as well, but of course we cannot switch a 3-phase load here. So what is required is a switch in between, a normally closed and a normally open 3-phase switch that actually switches over from one 3-phase load to the other. But these switches are activated by our relay here. Then there is a mode for hot water heat pumps. To be honest, we are a little skeptic at MyPV for the combination with heat pumps. Why is that? PV power changes all the time. Yeah, we have clouds moving around and the excess power changes permanently. But heat pumps, once they have started, they purchase a certain level of electric power, and they cannot scale up and down their power input. It's an electric motor for the compressor, and this is not flexible normally. So, and by the way, this is a mechanic hydraulic system. It cannot be switched on and off and on and off from second to second. This needs certain time to run, and then it needs a certain time to shut down. You cannot change the load on the heat pump every second. This is what can be done with immersion heaters. Nevertheless, there is one important question. What if there would be enough excessive energy to run the heat pump? And for this answer, for this question, there is the mode 4. In mode 4, we can use the relay here to release a heat pump. For example, a heat pump that has an SG-ready input potential free contact. This is possible, and in that way the heat pump can be included into the energy management. I recommend this for systems where there is no superordinated control, so no smart home system. If there is a smart home system, then it's usually the better way to use this smart home system. Let's say an SMA Sunny Home Manager, for example, which controls the heat pump as well. Then I would not recommend to do this with the Ector. But for every project where there is no smart home system available, this can be done with the Ector. And we are not doing the linear power control on the heat pump. We just switch the heat pump on, we release the heat pump, but we do the linear power control on the immersion heater. Good. This was mode 4. Mode 5 is this new topic for low energy buildings that I have mentioned in the beginning. Remember the new buildings with a very low demand of space heating energy. And for these buildings, we think about replacing the whole conventional hydronic building installation with cables now. So we are removing all the pipes from the building, and we are also doing the space heating here. We are using electric heating mats in the floor to use excessive power for heating. And beside a hot water boiler, this is possible for 2 electric space heating circuits. For European climate conditions, as in Austria here, there is of course the question what happens during winter time, what happens during December, January, when there will not be enough excessive power from the PV panels. The answer is that also for the space heating zones, there is a boost backup mode available. You can adjust a certain minimum temperature which has to be ensured at certain time frames, and therefore energy from the public grid is used as well. During the day, of course, the system can work with excessive power from the panels. So this mode works for new buildings with a very efficient insulation, so with very low space heating energy demand, and it works for buildings that have a relatively huge PV system. I'm talking about 10 kilowatt peak systems now at low energy houses. What we are doing is actually the same principle that is used by the heat pump. So we are not using the electric heating element in the normal way. It's not switched on. It takes power from the grid one by one. This is not what we are doing. We are feeding environmental energy to the system. We are using the PV system. And the heat pump actually does exactly the same. It evaporates a cooling liquid, it evaporates it with energy, with heat from the ambient air on the outside, and together with the power that is required to run the heat pump, it releases the energy to the heating of the building. What has changed is the physical energy carrier. We are not using a cooling liquid, we are using wires now, and we are using the same energy source, the same primary energy source, which is the sun. So at the end of the year, when this building requires less energy from the public grid than the building with the heat pump, it's not only easier to install, it's not only cheaper, then it's also the greener solution, and this is what really matters. It's the greener solution. And by the way, a system that works without any moving parts does not emit any noise, and it's also maintenance free. This is the future for building installation at low energy buildings. This is our point of view. What we are doing for many years very successfully is hot water heating from PV. We can do this every time. But this is a brand new topic, and of course there are already projects with this. This is a building in Upper Austria. The inclination of the roof is very important for Europe because this building has to be free of snow. This PV array actually, it has to be free of snow, and this is what planners have to consider. This building is a single family home. The specific demand for for space heating energy is 50 kilowatt hours per square meter and year. And actually this is the building should be a little better than this. This is the upper level where we say this technology works. But beside this demand for electric space heating, the operational costs were so low. We already have a 1 year monitoring finished, and the owner of the building had an energy bill of only 750 euros. And this includes electricity, this includes hot water, and this included space heating. In my building here, I'm using more than 750 euros per year just for electricity. I do not have hot water and I do not have space heating for this price. But for this building and for all new buildings, this is an option, and this is possible by cables instead of pipes. Good, very nice projects. Many of those are in the pipeline. Then there is mode 6, and I'm skipping over this. It's a little faster. Of course, we can adjust 3 space heating zones on all 3 Ector outputs. There is a mode 7 where we also can do the RPM control of a hydronic pump. It needs to be a special pump. It is by the manufacturer Vilo. We can heat up a very huge storage tank, stratification perfectly with stratification from top down when we're using an external pump. This is also possible. Very special operation mode. What is more important for all of you who are working with off-grid projects is mode 8. This is a frequency mode. And for mode 8, we do not need an Ethernet connection at the bottom here, because the set point signal for the Ector power output comes with the AC frequency. And the AC frequency can of course only change in off-grid systems. This is not possible in an on-grid system where the frequency in Europe is always 50 Hertz, in North America it's always 60 Hertz. But for off-grid systems, this is a way to do the energy management. And the energy management that happens is in between the battery inverter and the PV inverter on the roof. There are 3 brands, SMA, Studer and Victron, who are using this principle when the battery reaches the state of full charge. And from this moment forward, the battery inverter has to protect the battery. He has to protect it from overcharging, and therefore the battery inverter needs to talk to the PV inverter on the roof. He has to tell him, decrease your power output because my battery is full. And there is no way to use the excessive energy instead, because all the electric loads are already supplied, the battery is fully charged, and there is no way to feed in. You are off the grid here. So what happens is that normally the PV system shuts down. Not in that case, because the Ector can detect the frequency increase and it starts up its power output linearly before the PV inverter decreases the power output. And in that way we can utilize energy that was wasted before. The PV system shut it down before, and now we are using the rest of the available solar yield for power to heat application. And of course there are those stereotype Austrian projects with our mountain shelters in the Alps, but we also have created amazing projects in Western Australia. This image is from an avocado farm where we use the excessive energy for hot water heating, and this hot water is used for the production process of the of the fruits. The avocados are washed there. And even more interesting is the project on the bottom here. This is a Belgium research station on the South Pole, and the Belgians, they were looking for a system to make their off-grid system more stable, because beside PV power they also have wind turbines in these off-grid systems, and to make the system more stable they were looking for dump load controllers. And they found the Ector as a dump load controller, and the additional benefit is that they have now hot water heating. They are melting the snow there for the tap water, and with the rest of the remaining excessive energy they are heating the garage where the mechanics do the maintenance of the snowmobiles. So this is an amazing additional benefit, and actually they were just looking for a dump load controller. Good. Advantages over other solutions. I have done a survey on the websites of our competitors and we have found a lot of interesting advantages here. All of them have the capability of linear power control. So we are not comparing ourselves here with an immersion heater that is switched in let's say 500 watt steps, 500, 1000, 1500. This is not PV ready. We are not comparing ourselves with those. For diplomatic reasons, I have inked their names here, but I can tell you there's two Austrian competitors, one German manufacturer and one Italian manufacturer. And what we can do only is we can offer our communication protocol. So we have open protocols for third-party control. We can control each output of these three phases here linearly. All connections of the Ector are pluggable. We have a color touch display on our device for very intuitive control. And I always say, when you can set the clock for the next morning to wake up, you are even able to set the optional boost backup here, because it's very intuitive, it's very clear. You do not have to take the manual for this. Good. Yeah, there are also other manufacturers who can supply three-phase loads. Many of the competitors here have a relay output as we do. This is not the great thing here, but we are the only ones that are that can be controlled by the frequency. You see the off-grid systems on the last slide here. This is only possible by frequency control, and we are the only ones who are able to do so. And then the rest of the lines here is what I call the manufacturer's homework. We are looking for quality when we develop and produce this solution. So our products, they fit to they are grid compliant with the rules of the grid operators, even in Switzerland where it is very strict. And we have all done our certifications in the test labs for electromagnetic compatibility, and this is very important. So look for quality, because this is what we do as well when we develop these solutions. Yeah, Ector and Ector 9S advantages. I have talked about this already. One thing I have not mentioned so far, it's the same as with the green AC Elva-E. You can use up to 11 devices in one and the same Ethernet network that can be controlled by one system, and then they are controlled with a master-slave principle, and you can set priorities between those power stages. At the end, this is a screenshot of our data cloud. It's now also possible to connect the Ector and the Ector 9S beside the AC Elva-E to the data cloud. And for private customers, this offers the chance to have access to their devices from everywhere in the world. You can see what the device is doing, what the yield was, how the temperature increased. For all installers, it offers the chance for remote maintenance. So for example, if you have to readjust a setting, it's possible from your office. You do not have to go to the site of the end customer. You can do this via the data cloud. And then there is the question where to buy. We have a very well developed distribution network in the German-speaking countries. With my colleague Talal, we are on the increase of our distribution network in other countries as well. In many countries there is already a distributor available. Just check out our website. Maybe you find a distributor for your country. If you are a distributor, just contact MyPV. We are always looking for new distribution partners, and it would be of course great for us if we can start up or create a new market in your country as well. Good. Talal, if you haven't already done it, just enter your email address in the chat for our listeners, please, so that everyone has your contact available. You will receive my contact data at the end of the webinar. So with the email where I'm going to provide the slides, you see my email address. And of course, I'm available for all technical information you might need to clear all the questions that are not yet answered in the webinar. And for all questions on sales, please contact my colleague Talal. He already wrote his email address into the chat room there. And we are looking forward to your contact, and we are looking forward to help you with your topics. Good. Detailed information is of course available on our website. Beside all the manuals, wiring diagrams, there are also all the marketing materials available for download. There are also records available of former webinars. Of course, there is our YouTube channel. We are uploading new explanation videos there regularly. Just check it out. It's for all the questions that are not answered yet, please contact us via email. We are looking forward to your email, and thank you very much, ladies and gentlemen, that you have spent your time with us now. We are already 12 minutes above time, so thank you very much that you stay with us here in the webinar room so long. And I wish you a nice evening or a nice morning, depending on the location where you are. For us, it's now nearly the end of the day, and I have to say thank you very much for your time. Have a good time. All the best. Stay healthy, and we'll see you next time, hopefully. Thank you very much.